which is sine x divided by 1 plus. Right? Now, if you want to create that sine x, which is on the right hand side in the denominator, we can multiply this fraction by 1. Okay? But the 1 will be like this. The 1 will be times 1 plus cos x, which is the conjugate of the, sorry, minus. So it will be 1 minus cos x over 1 minus cos x. Okay? Please take note that this is equal to 1. Okay? Why we do that is for us to be able to simplify and be able to get the right hand side. Right? So when we multiply here, we end up getting sine x times 1 minus cos x all over 1 minus cos squared x, because 1 plus cos x times 1 minus cos x, if you have been following, it gives you a difference of 2 squares.
Yes.
Right? And then the denominator is equal to sine x squared. Okay? So that denominator is equal to sine x squared. Alright? Once we get here, it becomes a little bit easy. So this will be equal to, now one of these two cancels with this. Okay? When that happens, okay, let me write it down. So sine x times 1 minus cos x all over sine x times sine x. So this will be that, and then you will get 1 minus cos x over sine x. Therefore, the left hand side is equal to the right hand side. Okay? If you want to simplify the right hand side to get the left hand side, you multiply the fraction on the right by its conjugate, which will be 1 plus cos x divided by 1 plus cos x. Then you simplify. You come to what's on the left hand side. Yes.
The conjugate is not always the denominator.
Yes, it's not always the denominator. Are you following?
Yes.
Okay, you too. Are you following?
Yes.
Okay. Right, let's carry on. Right. The second one, you can also do the same. Okay? It's in actual fact, it will make the question very, very easy. Right? So either way, we can do it the left or the right hand side. So I'm gonna do it from the left hand side. Okay, let's do it from the right hand side. Huh? Okay, so the left hand side, we have sine theta times cos theta all over 1 plus cos theta. Okay, so this will be equal to sine theta times cos theta over 1 plus cos theta times 1 minus cos theta over 1 minus cos theta. Okay, once we do that, remember this is a monomial. This fraction is a monomial. We get sine of theta times cosine of theta minus sine of theta times cos squared theta. This is all over 1 minus cos squared theta. Okay? Then we take out a common factor in the numerator. Okay? Well, I think, okay, it wasn't that necessary for me to multiply because I'm going to go back to what I did earlier, but it's fine, I'll carry on from here. Okay? So to create that numerator 1 minus cos theta, I need to take out a common factor. Right? So I'm going to do what I just did again. So this will be equal to sine theta times cos theta times 1 minus cos theta all over sine squared theta, which is sine theta times sine theta. Okay? Then this sine theta and okay, let's see what's on there. There's tan there. Now, because there is tan on the others, it means we must have sine and what? We must have sine and cos. So this sine and that sine are going to cancel out. What?
Since time,
No, it's very simple. Did you pay attention to what I did that I think it was yesterday? I hope you are aware that cos theta over sine theta. This means this, right? Times 1 minus cos theta. Then this would be 1 over tan theta times 1 minus cos theta. And that will give you 1 minus cos theta over tan theta. Yeah? Okay, so this is equal to the right hand side. Okay? All right. Just that you see initially I want to start the numerator and that numerator. Then I realized that later I need to factorize. But it's exactly the same. All right. Okay. Any question? Then, but you has got any question? Yeah. Okay. All right. Let's carry on. Right. So this will be the end of proofs of identities, right, for grade 11. But it's important. Can you stop talking? Stop talking. Right. But as we move forward, you are going to find that proofs of identities, they are going to come back in metric as well. But in metric now, you won't be taught from scratch like how I did here. You'll be expected to know how to do proofs of identities. They will just be expanded a little bit. New concepts will come in to the proofs of identity. They are very important, and you are going to see them in your formal assessment on the 31st of March, your June examination, your end of year examination. And next year, they will be coming a lot. Okay, so you have to do a lot of practice. All right, so the next aspect, we are now going to combine identities, that is the two fundamental identities, and reduction formulae. Okay, the two can be merged. All right, so we are going to do some questions where we apply reduction formulae together. So I want you to write this heading. Okay, your textbook is a very good textbook and you are the first group to use it. No, I'm serious. Okay, so write this heading, using identities together with reduction. This is one of the best textbooks out there at the moment. Why are you not ready for the lesson? Your book is closed. Your body language is like, I don't want to be here. Maybe I want to go somewhere. Well, yeah, if you want, just write these 2 points. We can write the first one first, and then write those 2. Just write all 3. This one here, that one, and that one. Okay, and then in my case, I'll just apply that. I was going to tell you anyway. So with regard to this part now, it's a combination of reduction formulae together with the application of those 2 identities. Okay. Can you carry on? Right. Let's move on to some examples. All right. Let's start with A2. I can't do every question. So we have got sine squared minus cos 180 degrees minus x times cos. Okay? By now, everyone should know that if there is a square here, the answer is always what? Positive. So this will be sine squared x. Then here, 180 minus x is in the second quadrant and cos is negative. So this sign will end up becoming a plus. So we'll end up getting plus cos x. Well, okay, before I do that, to avoid unnecessary confusion, so I'll put minus cos x in brackets times cos x. Then you end up getting sine squared x plus cos squared x. And the answer will be a 1. Okay? So we have applied reduction and fundamental identity. Okay, we've combined the two. All right, let's carry on. Like your one. Okay. Then 4. So this is tan 225 degrees plus sine 180 plus theta times sine theta. This is all over sine 90 minus theta. Okay, so tan 225 is in the third quadrant. So it's the same as tan 180 plus 45, so that's tan 45. Right? Plus sine 180 plus theta. 180 plus theta is in the third quadrant. Sine is negative, so that's minus sine theta times sine theta all over cos theta. Okay? The denominator is a coratio. Alright? Then tan 45 is 1. It's a special angle. Then here we get 1 minus sine squared theta all over cos theta. Okay? But the numerator is equal to cos squared theta. Divide that by cos theta. The final answer will be cosine of theta. Okay? So, in terms of mark allocation, right, you get 1 mark there, 1 mark there, another mark there, and then using the fundamental identity, and then the answer. So a question like this could be 5 marks. Okay? If you know your stuff, you have all those marks. If you know your stuff. Okay. Alright, so I've introduced this. I'm sure you have an idea of what you're supposed to do now. So let me give you a class exercise. All right. Okay, it's going to be a combination of assessments. Right, I'll provide you with more details about that. Okay. Okay, can you stop talking? Can you do number 7? Hey, can you minimize talking, please? You're supposed to be busy doing that, number 7. Okay, where is Apiwe? And Luto, where is he? Is he sick or what? I wonder, this is not a good idea to not be at school. And Riley? And Talia? Rianka as well. So there are 5 people who are not here. All right. Have you finished? It's so easy that you should not take so long to do it. Right. Have you finished? Okay. Okay. So number 7. So we have 1 minus cos squared 180 degrees plus theta all over sine minus theta times tan 360 degrees plus theta. Alright, so this will be equal to, now this part here, you don't have to think about it. As long as there is a square there, you get a positive cos squared theta. Okay, so that will be 1 minus positive cos squared theta. Is that clear to everyone? Yes. Yeah, but there's a common mistake where if I block that, if you simplify that, some letters they write a negative cos squared theta. It's a big no. It's always what? Positive. Yes.
So you not start off by making that sine squared.
Which one? No, you have to, there's a mark for reduction. You have to, you cannot just start writing this is equal to sine squared theta. From here you say sine squared theta. You lose a mark for reduction.
No, so I got it sine squared theta and then you open up sine squared.
How did you get sine squared from here?
The 1 minus cos squared.
Okay, be very careful. It's not always that you convert 1 to sine squared plus cos squared.
So
Normally,
the 1 minus cos I convert to sine.
And let's do things step by step. Okay, let's do things step by step. Okay, I reduce this. Okay, you are rushing. Look here. From here I move on to that. Right? 1 mark for this. Right? So I'm doing, I need to do it step by step. Then sine minus theta, that's minus sine theta, times this angle is in the first quadrant, so that will be positive tan theta. So we have 3 marks so far. Okay? 3 marks. So that's 1 mark, that's another mark. Alright? Then the numerator, we can write it as sine squared theta. That will fall over minus sine theta. Now tan theta, we can write that as sine theta over cos theta. Now check this. You get 1 mark for this. Right? Another mark for converting tan to sine over cos. So 5 marks so far. If you know yourself, it will be a harvest. Yes? Right? If you know yourself, it will be a harvest. Right? Then from here, you need to be aware that we have in the numerator sine squared theta, then convert the division line to a division sign. Okay? So if you do that, you get divided by minus sine squared theta over cos theta. I multiply this minus sine theta and the positive sine theta, then you get minus sine squared theta. Well, we could put this in brackets. Okay? Then be aware that the denominator of that sine squared theta is a 1. So that will be times cos squared theta over negative sine squared theta. There's a negative sine theta here and another negative sine theta. There's multiplication. So you get minus sine squared theta.
Yeah, but the cos. But the cos, so how do you get straight?
Okay. Okay, listen, you must say it properly, right? So you put a 2 there instead of for the cos, you put a 2 over 1. It's just a silly mistake that I made.
Yes.
Right? Okay, let's. Do you know that? Okay, Do you know that some of you, when I mark your work, you also make that silly mistake? I will give you an example. Wait. Yes, wait. Okay, wait. I just want to clarify to you. There is, if you remember the recent March test you wrote, there was a question for nature of roots where you were supposed to substitute, I think, k equal to 5 or x equal to 5.
Yeah.
I think the last term was a 15 or something. Someone saw it as a 5, but I didn't penalize because the math was correct. Do you understand what I mean?
Yeah.
But they saw it with their eyes as a 5 instead of a what? A 15. So it does happen. Alright. Then from here, that sign squared then your denominator here should be a negative, so the final answer will be minus cos theta. Okay. All right.